We are TraumaCare and we are working on an antibacterial coagulating gel spray for traumatic wound treatment. So my name is Emily Byrne. I'm our team lead. I'm joined by Tron Nguyen, Oscar Voller, Grace Billingsley, and Alfonso Gomez de Leon. So we are working, as I said, on an antibacterial coagulating gel spray for traumatic wounds. Our product utilizes fibrinogen and thrombin for our procoagulants, copper nanoparticles for our antibacterial agent, and agarose gel as our base. So the market segment that our product falls into is emergency care, targeting patients who require immediate medical attention due to sustaining a traumatic wound. Our primary customers will be hospitals and emergency medical services.
The material inside of our product will be an agarose gel, which will provide a protective layer for the wound, and will also contain copper nanoparticles, which provide an antibacterial agent to help prevent infection inside wounds. It will also contain procoagulants, fibrinogen, and thrombin, which will spontaneously form into fibrin, which mimics how the body naturally coagulates blood. This is how our product will look like. It is similar looking to a spray can and will contain two separate compartments that will separate the fibrinogen and the thrombin so that it don't spontaneously form into fibrin until it is injected from the nozzle.
Our product utilizes fibrinogen and thrombin in order to mimic the natural blood clotting cascade in the body, then adds copper nanoparticles into the gel to add an antibacterial agent and help prevent infection. Considerations for the device include preventing the bleeding out of patients while still maintaining healthy tissue and not damaging or irritating the wound. These are the technical models which we utilize for our design. Our product is currently competing against the QuikClot hemostatic gauze as well as the Arista absorbable hemostat powder.
Our device will utilize a coaxial nozzle that will have a diameter of 1/4 of an inch, and the technical model below will help us achieve an ideal ejection flow rate of the gel onto the wound. Regarding the manufacturing, our gel will be enclosed in a stainless steel cylindrical can that will have a diameter of 3.5 inches and a height of 6 inches. There will be two chambers inside that will be connected by the coaxial nozzle to achieve an ideal ratio of copper nanoparticles to fibrinogen, and the can will be pressurized by nitrogen gas.
So what problem does our product address? Well, blood loss is the leading cause of death for trauma patients, accounting for more than 35% of all pre-hospital deaths. In order to minimize these deaths, our product aims to stop bleeding in a quick, effective, and easy-to-use method. We've selected our final design concept and are working on finalizing technical models for validation testing. From there, we'll order materials and start building and testing our initial prototype. We'd like to thank Dr. Chang, Dr. Grossman, and Dr. Becker for their expertise and guidance as our mentors this semester. Thank you for listening.